What exactly happens when a million people hit send on an AI prompt at the exact same time? And why don't the servers just instantly melt down? Today, we're jumping right into this explainer to unpack a seriously hardcore interview with Simon Moe, the co-founder of vLLM. We're going to pull back the curtain and reveal the unseen open source backbone that is quite literally keeping the entire AI industry alive right now.
It's a crazy problem when you think about it. In traditional machine learning, you classify an image, right? And you get one simple output, done. But with large language models, when you hit send, the system has absolutely no idea if it's going to generate a single word or a sprawling 5-page essay. Delivering that kind of unpredictable, non-deterministic text to millions of users without the whole thing crashing, that requires some entirely new, next-level engineering. So to really grasp how this actually gets solved, we first need to look at the massive bottleneck in the AI industry. Section 1, the AI inference bottleneck. You know, you really can't just drop a massive billion-parameter model onto a GPU and expect it to magically serve millions of people. It doesn't work that way. You need an inference engine. Software like vLLM sits right there between the raw hardware and the AI model itself. It essentially transforms raw compute power into a stable intelligence endpoint. And it does this through some incredibly complex memory management and request batching. And I absolutely love this point from Simon Moe. He says that inference engines are basically the databases and operating systems of the AI era. It's like you wouldn't try to build the modern internet without Linux, right? Well, developers literally cannot build the next generation of AI without this deeply embedded open source infrastructure. Okay, let's move on to how developers are actually accessing AI today and why the whole industry is going through a massive strategic shift. Section 2, escaping the wrapper trap. We've really seen an evolution here. Think about pre-2020. If you were working in AI, you were probably downloading models like BERT or ResNet and just running them on whatever local GPUs you could scrape together. Then, we hit the era of closed APIs between 2020 and 2023. Super convenient for sure, but you had zero control. Fast forward to today, and we are in the middle of a massive open-weight renaissance. The community is demanding frontier-level intelligence, but they want it entirely on their own terms.
And here is the harsh reality. If your entire startup is basically just a thin wrapper sending API calls to a closed model, you have zero defensibility. Serious builders know that to actually survive, they need to do their own custom post-training and use very specific inference tricks that closed vendors just won't allow. So relying on open source is really the only way to build a truly proprietary AI product. Which naturally brings us to the great divide in AI right now. It's this intense battle between proprietary closed models and open-weight infrastructure. Section 3, the battle for control. When you stack them up against each other, closed APIs basically mean unpredictable downtime and zero data privacy. Open weights, on the other hand, mean you get custom SLAs, totally secure data retention, and absolute system control. Imagine you're building a voice agent for a huge customer service center. You need to know with absolute certainty that the model will respond in exactly 500 milliseconds every single time. With a proprietary API, you hit an arbitrary rate limit and boom, your business is offline. Plus, with open weights, your highly sensitive enterprise data never has to leave your own servers. But honestly, it goes even deeper than that. Centralized API moderation filters are a notoriously blunt instrument. We've seen legitimate researchers who were just studying GPU memory kernels find their critical work completely blocked simply because a closed AI falsely flagged it as a security threat. False positives are a huge headache. On the flip side, there was a situation where Hugging Face experienced a cyber attack from an unsandboxed model. Do you know how they handled it? They actually used a fully controllable open source model to safely contain and analyze the threat. Total control matters. And this totally flips the whole narrative that open source is somehow this slower, cheaper alternative. It's not. By unlocking the fast modes on engines like vLLM, developers are out there hitting up to 500 tokens per second. Because you own the entire stack, you can heavily optimize that inference engine for your specific hardware. The result? You're executing tasks 2 to 3 times faster than even the premium tiers of closed models. But here's the obvious question. If these incredible open models, which literally cost hundreds of millions of dollars to train, are essentially being given away for free, how does the underlying economy actually work? Let's get into Section 4, the pharmaceutical AI economy. You really have to think about training a frontier model as a chaotic $100 million gamble. It is exactly like pharmaceutical R&D. You might endure 5 massive, incredibly expensive failed training runs where everything just crashes and burns before the loss curve finally drops and you get a working model. You desperately need a robust economic engine to fund these moonshots, or else the entire open source movement would just collapse under its own weight. So here is how the sustainable loop actually works in practice. First, these labs endure millions in upfront compute costs. Then they release the weights to build a massive global ecosystem. Now, individual developers get it for free. But the massive enterprises that cross specific commercial revenue thresholds, they pay for commercial licensing. And it's that enterprise money that ends up funding the next massive R&D cycle, all while keeping the baseline ecosystem completely open. It's a brilliant setup. Finally, let's look at the global race for the absolute future frontier of AI. And we really need to address a major misconception here. Section 5, the future AI frontier. There is this persistent rumor floating around that international open models are just secretly distilling or basically copying data from closed US models. But that idea completely misses the mark. Distillation really only helps with basic instruction following. It misses the reality of how true groundbreaking AI capabilities actually advance.
See, the true secret sauce isn't just stolen data. It is recursive self-improvement. You simply cannot distill a complex reinforcement learning environment where a model literally writes code, renders it, and then loops back to improve itself. That is true first principles innovation. Just to give you an example, a recent open model became vastly more efficient by entirely removing a core architectural component, the rope embedding, which handles how words relate to each other. And the crazy part? It was removed by the exact same researcher who invented it in the first place. That isn't copying. That is just hardcore, brilliant iteration.
As open infrastructure continues to set the global racetrack for innovation, let's do a rapid, hardcore recap of this unseen backbone. 1. Inference engines are the new operating systems. 2. Smart startups are escaping the wrapper trap. 3. Open weights guarantee latencies under 500 milliseconds and give you total data control. 4. Enterprise licensing is what actually funds that $100 million open R&D loop. And 5. True open innovation is driven by reinforcement learning, not distillation. So, your one-sentence takeaway for today. Open source AI is no longer just a hobbyist playground. It is the absolute mandatory, high-performance infrastructure for the future of enterprise intelligence. Now, I have a hardcore debate question for you all. When it comes to the path to true AGI, will it ultimately be locked down as a closed corporate secret, or will it be built on a globally shared open foundation? What do you think? Drop your arguments in the comments below. And finally, be sure to leave a comment down below to grab our complete mind map of all the open source infrastructure tools we mentioned today. Keep building, keep learning, and I'll catch you in the next explainer.